All right, so our next topic is function notation, right? The last lesson we looked at determining a relation, which is any kind of points or data that you have that you can graph, determining whether it's a function. Again, the whole point of that is when you have a function is predictability. If you have an x, you get this y. All right, so now we're going to look at a little, continuing on with functions, but definitely in a different light here, is we're going to look at something called function notation. And to start off is this: if you have the equation y equals 2x squared plus 1, and it is a function because it's a parabola, all you can do is you can express it as f of x, that's how you say that in function notation, is equal to 2x squared plus 1. So all that has happened in the function notation is that the y, instead of y equals, you have f of x equals. Now, there is definitely reasons for that, and if you understand function notation, it helps short form things, and it makes it you can put a lot more information in a much smaller equation. That's the whole purpose of function notation. But again, you got to know how to use it. All right, so that's what we're getting to. Now, some examples of function notation: you just don't have f of x. You could have f of x equals 4x squared minus 2x plus 8. You could have a g of x equals 5x minus 2. You could have h of x equals x squared plus 3. All it means is when you have a different letter, you just have a different equation. So typically what you'll see on textbook work or any kind of function stuff is that they'll use f of x as your first equation. And then if there's two equations in the question, they'll use g of x. And if there's three equations in the question, they'll use h of x. Okay? So it's not like it's just in each and every question, you have to label your functions, and so definitely the first one's always f, generally used, then g, then h. Doesn't mean they can't switch it up and use a t of h or something, or t of x, but those are the most common ones. Now, here's what we're all about for right here on this lesson. We're going to find f of x, which means find your y value for values of x. All right, so that's all that's happening here. Now, there's two different ways that we're going to look at. The first one is a graph, which is really easy if you know what you're looking for, impossible if you don't. So I'm going to find f of -4, f of -2, and f of 0, and f of 3. So four y values I'm going to find. And that's something here is that really when I'm asking for f of -4, that means to find x, to find y, because that's what f is, for x equals -4. All right, so that's what confuses people about function notation, is that I have an f of -4. You see the x value, so you're thinking, oh, I got to find x or something. No, this whole f notation here is that y. It's just short forming it, saying, hey, x is -4 in the inside here. What's the y value for when x is -4? That's what it's asking. So if I look at my graph here, what I'm going to look at is where x is equal to -4. So I go along on my graph, I look, there's x equals -4. What is my y value, or what is the height of my graph? It's 0. Again, really easy to find if you know what you're looking for, hard if you don't. My next one here is f of -2. So now again, find your y value when x is equal to -2. So I look along my graph here. There's x equals -2. I move up, and I have a height of 3. So f of -2 is 3. All right, so again, that's saying my x is equal to -2, my y value is 3. Or a nice way of saying that's the point, -2, 3. Same thing in non-function notation. I have f of 0. So again, my x is 0. I want to find my y value, so I take a look at my graph. Don't go left or right. There's my x is 0. I go up, and it is 1. All right, and then finally, f of 3. Where x is 3, what is the y value? I move along on my graph here. I go down. It's actually -1. So again, that is finding our y values for a given x value using a graph. Now, next up, what we're going to do is with an equation. No graph. So I'm just going to have to erase this. All right. So the first or the second example. So now we're looking at finding our y value using function notation for values of x. And so the first example, well, I'm going to say if. So I'm now coming up with my two functions. So I have f of x is equal to 3x minus 2. That's our first one. And since I've got two equations for this question, I'm going to have a g of x, which is x squared plus 1. And here's what I want to find. I'm going to find a few things here. All right, so A, f of 2. That's what we're going to find. All right, so now a couple of things. I have two equations. I have an f of x equation. I have a g of x equation. If I'm finding f of 2, that means I'm going to use my f equation. So I'm going to use that 3x minus 2. Now, within that function notation, it's also telling me this. Your x value is 2. So I'm going to use the f equation, and I'm plugging in x is 2. And so instead of a 3x minus 2, it's already telling me, for using function notation, that my x value is 2. So it's telling me what x value to sub in so I can find my y value. All right, and so f of 2, well, I have 3 times 2, which is 6, minus 2 is 4. So f of 2 is 4. It's a nice way, again, of saying in function, in terms of graphing, x is 2, y is 4. All right, B. What else we got here? G of 11. All right, so again, in a similar fashion, in functional notation, the g is telling me which equation to use. The 11 is my x value. So I go over to my g of x equation, which is x squared plus 1, but I do know x. So I'm going to put some brackets there, plus 1. And again, the notation is telling me that in this case, the x value actually is 11. All right, and so now I just do some calculations to find out what g of 11 is. I have 11 squared. I believe 11 times 11 is 121. And I have this 1 here. And so I can put those two together. And so g of 11 is 122. My x value is 11. My y value is 122. All right, C. Let's see here. Now we'll skip C. I'm going to go with D on my note here, where I have f of w. Okay, that is a weird one. So this is kind of what we're going to get into now is because my x value is a variable, my answer is going to be a polynomial. Now, again, same idea. It's telling me which equation I'm to use, and it's also telling me which letter gets subbed in for x, or what value gets subbed in for x. This time it's a letter. And so I still have my f equation here, which is the 3x minus 2, but I'm substituting out x, so I'll put it in there like that. I have a bracket. Function notation is telling me to put a w in there. Oops, there we go. There's my w. And so, well, 3 times w is 3w minus 2. And so all that happened is because I was subbing a w in for x, w just replaced x. And so instead of f of x equal being 3x minus 2, well, f of w is 3w minus 2. That's all. Just replaced the x with a w. And I can't go any farther because, again, polynomials, not like terms. All right, E. What we got now? Okay, now we're getting stepping up a bit. We have g of 5 minus 2 in brackets. Now, here's the thing with function notation, is that if you have numbers inside the brackets there, you can do the addition, or I guess in this case, the subtraction. So I have g of 5 minus 2, which just means it is g of 3, which now I know how to figure out because that is telling me to use the g function, but put a 3 in for x. And so my g function here is x squared plus 1. And so we have 3 squared plus 1. All right, so I just substituted a 3 in for x, and I got squared. I believe that it's going to be 9 plus 1, which gives me a 10. Again, because we had a number inside the function, we're going to get a number answer. All right, F. Now here's something a little different. I have g of 5 minus g of 2. So similar but different. These are separated into two separate functions. Where here this was just one function where I could do the subtraction inside. That's not the case here. What g of 5 minus g of 2 is saying, I have to substitute into the g equation twice, then subtract the answers. And so what I end up with is I've got g of 5 here. So again, the g equation is x squared plus 1. So I'm going to have a 5 squared plus 1. So that there is g of 5. Subtract g of 2, which again, the g equation is x squared plus 1. Well, I'm plugging in a 2 for x. So I have 2 squared plus 1. All right, let's see here. Yeah, I can just figure it a little math. I have 5 squared plus 1. That is 26. Subtract 2 squared plus 1. So 2 squared is 4 plus 1 is 5. And so I have 26 minus 5, 21. And so what you can see is g of 5 minus 2 is different than g of 5 minus g of 2. All right? So these two are not the same thing. All right, now clear off my board here. I need my equations though, because that's the equations for this question. All right, so what do we got next here? G of 2W, okay? Or this is a question G, and it is G of 2W. All right, G and G of 2W this time. All right, so again, I have a polynomial inside the function notation. So that means our answer is going to be a polynomial. All right, so again, it is saying take the G equation, but yet sub in 2W for X. All right, so again, the G equation is X squared plus 1. But as I said before, I'm subbing in a 2W for X. All right, so now I got to do a little bit of math. The reason I have this question in here is because we have a 2W squared. When you are having a power law, the expanded power law, you have to square everything in the brackets. So 2 squared is 4. W squared, well, is W squared. And then because those aren't like terms, we're done. That's our answer. Again, we had a polynomial inside our function notation, means we're going to get a polynomial answer. All right, let's see here, H. I'm looking at f of 5x plus 1. So now again, we're going to have a polynomial answer because we got a polynomial inside our function notation. It's telling us to use the f equation and to sub in fx or 5x plus 1 into x. So again, the f equation is 3 times x. So I'll put a bracket in there because I should put a bigger bracket. We'll get there. Minus 2. All right. Function notation is telling me to put a 5x plus 1 in here. Should have made my bracket bigger. 5x plus 1 goes in. All right. And then again, I can simplify. So I have this 3 in front of my bracket. I call it the rainbow rule. Some teachers call it the distributive property. So I'm going to stick with that, with the rainbow rule. So 3 times 5x is a 15x. 3 times the positive 1 is a positive 3. And then I got this minus 2 that wasn't in the bracket. So I just leave it on the outside. I do have some like terms I can get to. So I still have my 15x, but 3 minus 2 gives you a positive 1. And so again, because we had a polynomial inside the function notation, we get a polynomial answer at 15x plus 1. All right, let's see. Last one. I call this I. We have f of x plus 4. All right, so again, I'm using my function notation. I've got to use the f equation. I'm going to substitute in an x plus 4 in for x, which is kind of weird. That messes people up in that you're subbing in x stuff in for x, but that's how function notation works. All right, so again, my f equation is 3x minus 2, so I have a 3 times x plus the 2. There we go. All right, and again, what's going in for x? This time it's x plus 4. Substitute that in. All right, and again, because I have a number in front of my brackets, I can do the rainbow rule. So 3 times x, that's a 3x. 3 times 4, that's a positive 12. And so I did my expansion, but can't forget my 2 here. All right. And again, I have like terms, so I can simplify this down to 3x plus 14. And there we go. So that is how we use function notation, a little introduction of how we find it using the graph. Also, how to find our y values when we know an x. Our next class, we're going to reverse it, where I'm going to give you the y value, and we're going to go the other way and find the x. All right, so I want to give you a practice here on finding the y's when you have an x. Like I said, next day we're going to reverse it. Just stop